Hello everyone, welcome to this XGSLab webinar. This webinar is meant to show the XGSLab users the new features we have introduced in the new version. So we have thought that a webinar for this specific version was important because we have introduced important changes in the workflow, and also we have made the software more efficient and also more accurate. And this is something the user must be aware of. So let's start with first of all, the presentation of the speaker, that is me. I am Daniele Cuccarollo, an electrical engineer. I think I can define myself an earthing specialist, just to be very brief. And the most important thing is that I have been involved in the development of XGSLab since 2012. So it is, let's say, a quite long time. Let's start with the first topic of the new release, the first area of the software that has been changed quite considerably. And we talk about the new multi-soils. As briefly described here below the title, the multi-soils introduces the ability for the user to analyze different soil scenarios in the same project. So in order either to decide which one best suits the case of study, or to decide which ones are to be used in a multi-zone soil model. Consider that here is the interface of the software now. We have the chance to pile up in the list of soils many soil models. So we have, as you can see, 4 records in this table. We have a uniform soil model here, another uniform soil model here, and 2 multi-layer soil models here. We have that all of them are in the project, and we need to decide which one we need to use. We have that the table, as you can see here, is very wide, can show you all the details of all the records. So you can see for each soil model all the layers, for example. And so you have some tools that allow you to handle the table in a very efficient and easy way. As you can see, we have collapsed it very quickly, and we can also edit each soil model that you have in the list of soils, and with a very, let's say, handy dialog box here where you can add, delete, modify any soil layer of each soil model. About the uniform soil models, they have a peculiarity, that is to say that all the uniform soil models are available for a multi-zone. So in case you press the button multi-zone soil model here on the main toolbar, you have the chance to arrange a zone list that is the same that was present also in the previous versions of the software. You can edit it by setting the coordinates of the zone, as we have always done, and also recalling the soil model you want to use for each zone. So the gist is that you can create many uniform soil models and then use them for, each of them can be used for a zone. So once you have created your list of soils, you have to apply your soil model that can be a uniform soil model, a multi-layer soil model, or a multi-zone soil model. So you have to choose the model type. Once you have chosen the model type, the panel is set, in this case, we have chosen the multi-layer soil model to that configuration, and here in the panel we can choose the soil model frequency dependence, as we did in the past. We can choose the soil model from the list, so the soil model 444 that we have in the soil list is chosen as a soil model to be used in the calculation. And finally, very important, we have to apply this soil model in order to use it in the calculation. After this, the other important new feature, or better, the other important new way to handle a part of the software is the new soil resistivity analysis. Basically, this tool that existed also in the past versions has been improved and structured in order to handle the new multi-soil. So we have now that to enter the soil resistivity analysis, we have to press on this icon, and this tool opens. Let's say that the gist of this tool is the same of the past, but you have to you can notice that it has been completely rearranged for the layout, for example, because in the past we had just one form to handle all the features and all the dialog boxes. Now we have two tabs, as you can see, the first for measurements and the other for the soil model. In this first one, we have that we can also handle in different ways as an option the chance to import the soil resistivity measurements for a multi-layer soil model or a multi-zone. This is important to be noticed because in the past this table was automatically set by the choice of the soil model we wanted to use, but you have to consider that now this soil resistivity analysis becomes before the choice of the soil model. So let's say you create different soil models directly inside this tool, and once you have created one or more of these soil models, as we have seen in the soil list, you choose the one you want. We have also that the picture that shows us the soil resistivity measurements has been changed, and here I take the chance to tell you that many of the 2D pictures have been changed by using this new graphical tool. Let's say that we have in mind to change all the 2D pictures in the future according to this new layout. We have started with the ones that are inside the tools we have now changed for this new version. So this new picture feature is complete with many options. So for example, the legend, where we also have the chance to tick the different tags in order to show just a part or some of the traverses we have imported. So the feature that was the tag filter in the past now has become a simple tick in the legend. We have also the chance to set up the scale of the axis in the way that we prefer. So as you can see, we can set up the minimum and the maximum for both axes. And also we can set up linear or logarithmic scale for both of them. And in this case, we see for both of them the logarithmic scale. Finally, we also have a dedicated tool to undock the legend in order to create an independent image where it is highlighted also the fact that by using our mouse, we can also read the different values of the picture. So I want to stress that this new way to handle the pictures, the 2D pictures, is a way that we have in mind to use in all the software. At the moment, this is not done for obvious reasons concerned to the time needed for this application, but in the near future, in the next versions, basically, this change will come step by step. About the soil model calculation, let's say that once we have completed the measurements application and also we have pressed the button continue that is included here, well, let's make a step backward here below, we can go on with the soil model calculation. Also in this case, we can find the same tools we had in the past. So the layer number setting, for example, where it is included also the automatic option. So the auto option is equivalent to the past auto tick box that was present. It is all the settings that we had in the past are still present. We still have the zone filter in case of multi-zone soil model. We have the tables for the layers calculation parameters where, as you know, we can set up the initial conditions, the lower constraints, and the upper constraints for the algorithm that calculates the multi-layer soil model. And one new thing that we have to do now is the choice of the soil model name. Since we have to here to create a new soil model that has to be added in the soil list, we also have the chance to name it. As you can see here, by default, the name is a simple one, that is to say, for multi-layer, it is ML and date and time. Let's say that obviously you can edit this name with a more meaningful name. And finally, you save the soil model that you have calculated in order to add it in the soil list. After this save, we can get back to the list, to the soil list, and we can see here the just saved model that we have calculated just one step backward. So it is also important to notice that we have also here highlighted the origin of the just saved model, because as you can read in that column, here we see that this model comes from the soil resistivity analysis. But for example, the previous default multi-layer model is a custom model. That is to say that it was created directly in this soil list. So it is also important, this kind of information. Finally, as stated before, but I wanted to remind you of this new operation that is needed. Once you have chosen in the soil model drop-down menu the model that you want, you can apply it in order to use it in your calculation. Well, here in this slide, I want to tell you that you don't have to be afraid of this new way to handle the soil model. Why this? Maybe in the previous slides, you have seen a very powerful tool, for sure, that allows you to handle many soil models. but maybe in some ways you could also have been puzzled by a so large number of soil models. So let's say that this is what I have shown you until one slide before this is what the software can do now. Obviously, if you just need one soil model, this is something very easy to handle. You just have to create one soil model, to choose that only soil model, and so you have no crowded list of soil models to be checked. And finally, you can apply it. The reason why we have implemented this new way to handle the soil model is also because of what is coming next in the software, and that I have highlighted here. That is to say, the multi-region model. The multi-region model is something that we have in mind to develop in the future, and this way to handle the soil models as a list of possible soil models is something that comes before this new development. So something that will allow you to handle the soil with also many multi-layer soil models in different locations. So something very powerful that needs anyway a rearrangement of the software. Let's go on with the other part of the software that has been reorganized and also improved. That is to say, the new soil seasonal analysis that has been improved and structured to consider also the moisture of the soil, not only the temperature. So, like in the soil resistivity analysis, we have a meaningful icon that helps us to open the tool. And at first, we need to enter the soil, the general information. The general information about the soil model, about the seasonal analysis. First of all, require the reference soil model from the soil list. So basically, we need to recall one of the soil models we have in the list of the soil models in order to use it as a reference to apply the seasonal analysis. Then we need also the soil type from the soil library, and this is very important in order to apply the seasonal and also the soil temperature and the soil moisture elaborations we need to do. And here we have a print screen of the soil library where are highlighted the properties that are needed in a soil in order to be able to consider also the moisture dependence. So we have, for example, that we have these four data, that is to say, the density of the dry soil and also the saturation point to be needed, and two coefficients that can be found in literature that have to be input in the table in order to be able to use that soil in the moisture tool. We can see both the soil temperature analysis for the soil and also the soil moisture. Here we also can see how it has changed if compared to the old seasonal analysis. We have also in this case that the tool has been arranged in tabs, not only in a single window with many images and values to be entered. So here we have all the data that are needed Here, so for example, the medium air temperature, the additional temperature to find the ground temperature using the air temperature, and for example, here the data about the difference between the maximum difference in a day about the temperature. So all the data without recalling all the data needed for the input of the soil temperature analysis, we can see that here we have all the pictures we also had in the past. For example, this for the annual ground temperature depending on the depth, and here you can see that we have used the new graphical layout that is much more flexible with all the tools that I showed you before about the soil resistivity measurements. So here the ground temperature for the two different times, that is to say the measurement time that is the 16th of July, and the calculation time that is the 5th of March. We have the normalized soil resistivity temperature dependence and the soil resistivity correction factor. After this, consider that we use a lot now that we have this multi-tab windows. We use a lot this button continue, as we have seen also previously. And by going to continue, we can go on with the soil moisture. The soil moisture needs as data input the precipitation data that are provided both as rainfall by month and as snowfall by month. Then we have other data about the latitude of the site, the curve number that depends basically on how much the soil is able to absorb the rain, and other data about the soil and its behavior when it gets wet. Here, some pictures about the showing of the annual precipitations. So we have both in blue the rainfall and in red the snowfall. We have the annual available precipitation. Let's say that this picture is really interesting, in my opinion, because as you can see, we have in the y-axis the precipitation in millimeter by day, and in the x-axis we have the days of the year. We can see that the precipitations are not so variable. This let's say, despite this spike that is in this period of the year. Let's say that this spike is due to the snow melting that happens in spring. So it is really interesting to see how this tool is able to consider very efficiently and very effectively also the precipitations, and also the precipitation of the snow and its melting that provides a wet ground in a delayed time, let's say. We have also the annual ground moisture by weight, that is to say the content of moisture in the unit of ground, and also in this case we have different behaviors depending on the depth of the soil analyzed. We have the ground moisture here. Depending, let's say, the moisture on the depth of the soil in the different days, the calculation and the measurement day, the normalized resistivity moisture by weight dependence, and finally the soil resistivity correction factor. This factor is very important because it must be coupled with, in this picture, with it must be coupled, the one of the moisture with the one of the temperature, and so the green is the overall correction factor. This is really important because once we set that we want to consider both the effects of the temperature and of the moisture, we can also decide a depth to scan here. So here we have decided half a meter, and then we can calculate all the other information. That is to say, here we have the correction factor provided for the set depth, so for the 0.5 meters, and we have it all along the year, so the correction factor during the year. And finally, we have the the modified soil model in red compared to the initial soil model in blue or violet, let's say. So here we have the complete analysis of the seasonal analysis, both considering the temperature and the moisture. Finally, the final step that we need is the name of the new soil model that we need to add to the soil, to the list of the soils. Consider that basically when you use this tool, the seasonal analysis, you take as a reference a soil model to be able to use it, as we have seen at the very beginning in the general tab, and then you create a new one. So when you use this tool, you do not lose the initial soil model. Let's say that you populate the soil list with a new soil model that has been, let's say, that has been modified by considering the effects both of the temperature and of the moisture. And in fact, here we have the modified soil model that is added in the soil list. And here we have the new soil model modified with the seasonal analysis. And also very important, we have that the origin of the just saved model is highlighted in order to understand if it comes from the seasonal analysis full, because we have used both the temperature and the moisture. Otherwise, the seasonal is not full, but simply the part of the temperature, nothing more. Let's go on with another very, very important new feature. Let's say that in this case, we have, let's say, not only rearranged the software, but also introduced a feature that I have to be sincere, we have been asked to add it for a long time, and finally that time has come, let's say, in order to add it. So we have basically introduced with the multi-limits feature the ability to analyze and to apply different touch and step voltages limits potentially to each calculated area. And let's see how we can do it. We can see that we have to go like in the past in the touch and step voltages part of the main toolbar, and we go to the form that allows us, to the window that allows us to calculate the limits. So what we have to do, let's say that the very different thing that we have to do is to set a name for the limit, and then we need to enter the usual parameters we have always used to calculate the limits. Finally, once we have calculated the limits with these given parameters, we have to add the limits to the limits list, because also in the case of the limits, we have a list of limits. And this is due, obviously, to the fact that we can use multiple limits. This is the list of the limits, so you can see that we can enter it from that icon in the main toolbar here, and we have that here the just added limit is highlighted. We can see, well, before this other slide, we can see in this table that the previous limits are one is without soil covering and the other is with soil covering. Obviously, the one with soil covering does not have just the soil covering, but also the thickness of the soil covering. So potentially, what I want to show you is that you can create a list of limits, and each limit can have its own characteristics. And let's say that the most useful aspect of this new chance that an XGSLab user has is that you can add also multiple limits, and each of them can have different soil covering layers. So this is really powerful in order to do what I'm going to show you. That is to say that when we go to the area calculation of the touch and step voltages, obviously, we have a new feature, a new box here in the panel on the left, a box that after having set the area calculation, after having maybe plotted the earth potential, and before making any evaluation of safe areas, we can, with this drop-down menu, associate the limits to the different areas. So it is also important to notice that you can do this correlation here, and let's say that this table is also built up in order to tell you what is the area you are handling, what is the limit you are applying to it, and it shows you also if there is the soil covering layer in the limit you are applying. But it is also very important to have a look to the legend of this picture, where you have that also the soil covering layer of the areas are described, in this case, in a simple way, because we have no soil covering. So beyond the calculation area that is selected, we have just a white area that are the ones with no covering. After having this correlation, after having set this correlation between area calculations that are 3 in this case, I wanted to stress also this, for the ones at least that are not used to the multi-area feature that we have introduced in the previous version, we have 3 calculation area, one here that is another here, a bit more large, and another small here. So we have applied no soil covering layer, or better, we have applied no limit with soil covering layer. So we have a plot here that highlights also with this red circle that we have a deeply unsafe condition in this part of the system. If we make anyway a step backward and we reset the correlation between the areas and the limit that we want to assign to each of them, we modify the limit of the TSV2 with a limit that has got a soil covering layer. So we have highlighted this here. Consider also that also the legend of this picture has been populated with an additional item here, SCL Gravel 2500, and the color is telling you that this area has got this soil covering layer. That color comes from this table, the library of the soils, that has now among the different information needed, also the color. So when you set up a soil covering, you can also set up a meaningful color in order to make easier to notice this kind of soil covering layer. After this, we can see the most interesting part of this new feature. That is to say that now, for the same area calculation that implies 3 different areas, the ones that we had before, by setting a different limit for this area, we have that this area gets safe. So obviously the important part of this new feature is that at the same time you can consider areas where you have soil coverings and areas that do not have it. Consider that this picture also highlights the presence of the soil covering with these labels. Consider that these labels, if you think they are a bit too, let's say, too much or too visible, can be also switched off by setting off the label the label button that we have here that now is not visible, but you know that in the software is present. So very easy also to make this picture as readable as possible. About performances and accuracy that have been considerably improved. Let's say that by an operation of refactoring and also let's say a better use of the different function that we use in the code of XGSLab, we have improved a lot the time needed for the different operations in the software. So, for example, the debug time needed has been improved between a percentage between 30 and 50%. So, especially for the ones who use the scheduler in the software, this is really important because the debug becomes also calculation time, especially in the, as I said, in the use of the scheduler. So this is really important. But anyway, also for the one-shot use of the software, the debug, in case you have a high number of elements, is considerably faster. About the main calculation, both in FD and in TD, we can say, generally speaking, that for sure we have better accuracy. This is due to the fact that we have taken away a property that I'm not going to spend time to describe it, but it was included in the settings. Now we have made it how to say, more adaptive, self-adaptive, considering the position of the layout related to the soil interface. So we have a better accuracy. Generally speaking, the performance is stable. Let's say that it depends on the case. As I said, in some cases it could be a bit slower. In some cases it could be much faster. So about the performance, let's say, generally stable. Anyway, about performances, a particular thing can be said about the main calculation in time domain. In time domain, especially in calculations that have got a number of elements that is not so high, so below some hundreds, let's say, we have a calculation time reduction that is up to 80%. Just to give you an idea, if you have if you remember one case of the tutorial of the time domain, that is the grid, the square grid, 60 meters by 60 meters, the time needed for that calculation in a machine we have here in our company has changed from 12 minutes to 3 minutes. So we have a really important gain on that side. About this other calculation, we have for all of them a considerable calculation time reduction. So you can see Earth potential area calculation 10%, magnetic field area calculation 35%, so quite considerable. Electric field area calculation 50%, and most important, in my opinion, among these ones, the shield main calculation 70% calculation time reduction. And I take the chance of this to say that, well, in my opinion, the shield module is one of the ones that have found most beneficial this new release of the software, because Shield has improved very much on different sides with this 2026 version. Some final note about the Academy. Let's say that the changes in the software are considerable. So we are going to update the Academy courses very soon. This is something we are going to do quite quickly, let's say within 10 days, let's say from now. But in the meantime, since we recognize that the change in the handling of the creation of the soil model is quite important, we have built up a new free micro course that is now available for free for anyone. And you can find it in the Academy, that for the ones that maybe do not know are in the help desk. You can go to the Academy section, and you can find this course that is a short course, but that shows you all the main changes and how to handle them. So consider that it is for free. If you are a licensed customer that is regularly keeping on its maintenance, you know that you can enter the help desk and have this course for free. So this is the last thing I want to tell you. So just thank you for your attention. You know that you can contact us by writing us at these different addresses or web addresses. So in case you have questions, anyway, now we are available. We still have some minutes to answer your possible questions. Just give me a moment to have a look at them. At the moment, I see no question. Okay, I see one question actually about the recording of the webinar. It has been recorded. The webinar, I will set it available for anyone well, for any participant of the webinar. There will be it in the cloud, but I will download it and publish it in our YouTube channel. We can wait some minutes in case there are questions about the new multi-soil, about the new soil resistivity analysis, about the performances also. Otherwise, we can greet you, and anyway, thank you again for your attention. Okay, I see that there has been a question about Just a moment. Yeah, some questions are arising. Okay. About the setting the zone in the multi-soil, I suggest you to have a look at the micro course that is for free in our academy. Let's say that this is just a webinar to show you the new features, but how to use it, let's say, keep as a reference the academy. It is very important. We are rearranging also the training of our user according to these different channels. I see also, okay. So about, there is a couple of observations from a user. The first one concerns the conductor libraries that this user says that are unable to export for multiple projects. And also some note about exporting the layouts from XGS. Let's say that this is not related to this webinar, but anyway, we can give an answer to both of these notes. Let's say that about the conductor libraries, we have changed in the 2025 version the way to export and import the libraries. Now, let's say that you can export them you can export them in XML file. The only thing about the importation is that you can import them before before setting a module. This is the attention you have to keep. When you want to import the libraries, you have to open the software, create the project. Before setting the module that you want to work with, import the libraries. In that moment, the import option is enabled, so don't be afraid of that. You just have to do it in the right moment. About exporting the layouts, you know that the exportation of the layouts from XGS is possible in many ways. You can export in CAD file from the XGL CAD. You can export also the distributions, so in a CAD file, but with the color code of the distributions. You can export in XML the list of conductors, so you have a bunch of options available in order to export the layout. There are some other questions I saw. Just give me from Tom. We have. Okay, so good question from Tom that is asking about the stability of 26 version. Let's say that this is a good question because we still label it as beta version in our help desk. Let's say that we have done it because we have released it just 2 weeks ago. I have to admit that as first trials, we still see some minor bugs, but no major problem. So let's say that we still would like to keep 2 weeks of beta and then or 2 weeks maximum, let's say, of beta labeling, and then we will set it for official 2026 version. Anyway, I think that you can start to work with it because we are experiencing on the other side a very good feeling in working with the 2026 version, since the changes and the improvements are a lot, not only in the features, in the number of the features, but also in the user experience, in the efficiency of the software and many other aspects. From Alexander, okay, well, I have already answered about this. Okay, so within 2 weeks we will have the official version. About Unai, Okay. So the Academy web page, just I make some step backward in the presentation. You have to enter the help desk. So you have to go to our website. So www.xgslab.com, and you have to find the help desk. And from the help desk, you have to enter your credentials, so username and password, and you will go to this page where you can find both the ticketing website. So if you have used the ticketing for the support, you know that aside the ticketing, you have also the academy. And from the academy, you have the chance to enter this micro course. Okay. So if you have other questions, please ask. Another question, I see any improvements on exporting the contours in KML or KMZ file? At the moment, we do not have worked on that side of exportation. Let's say that the last times I have used that tools, the working was very efficient. Anyway, if there is some information that is needed also on this side, it can be asked in the ticketing system we have. Okay, I think we have run out. We have run out of questions. It is almost an hour. We are live. Let's say that we can say that this is all. As I said, you will receive the recording, and anyway, we will publish it in our YouTube channel in order to make it available for all the ones that are interested in the software. Thank you again to have participated at this webinar, and see you next event. Bye bye.